Bismillahirrahmanirrahim. Today our topic is finite automata, implementation of finite automata in Python. For this we are going to take a very simple example. The example is a language of word starting with A or an alphabet A comma B. We have alphabet A comma B, two alphabets, and we are going to discuss a language starting with A and follow any combination of A and B. For this, the regular expression is A starting with A and following any combination of A comma B. So the regular expression is simple A multiplied by A plus B whole static, any combination of A plus B. For that, the deterministic finite automata is implemented in this graph. We have four states: Q0, Q1, Q2 and final state. So we need to implement the finite automata for the basic condition. The basic condition is starting with A. So Q0 is the initial state. Now we have to take transaction to Q1 over A. So if we go through input letter A from Q0 to Q1, this is the final state. The language, this language contain A starting with A, then AA, then AB, then AB, AA, BA, and BB is not included in this language. So A, B, A, comma, A, comma, A, B, B. Every letter must be starting with A. This is the language of this regular expression, starting with A, starting with A, starting with A, starting with A. A string like BA, like BA, like etc. These are not included in this language because it does not start with A. So Q0 to Q1 is a transaction which is a final state. Now if we implement this regular string on this finite automata on the first A, it goes to the first state, Q1 state. On A, any combination of A comma B, it will go to the Q2 state and then follows by any combination of A comma B. On B, like this, BA, B, Q0 to dead end and any combination of A, B. So it is not a finite state, it is a dead state. So this is actually a finite automata for this regular expression. Now we are going to implement finite automata in Python or any other language. We need a transaction table. So these are the states. We have Q0, 1. Q0 is the initial state, so we place minus with Q0. Q1 is the final state, also Q2 is the final state, and D is dead end. So these are the states, these are the input symbol A comma B. How to create a transaction table? So on Q0, from Q0 in input letter A, for transaction Q0 on input letter A, it goes to Q1, it goes to Q1. So it goes to the first state on Q1. Now from Q0 on input letter B, it goes to dead end. From Q0 on input letter B, it goes to dead end. Now we are going to discuss the state Q1. On Q1 on input letter A, it goes to Q1. 2. It goes to Q2. Same is from Q0 on input letter B, it goes to Q2. Now we are going to discuss the state Q2. On Q2 on input letter A, it goes to Q2 again. So on input letter from state Q2 on input letter B, it also goes to state Q2, which is a final state. Now the dead end contain transaction for A comma B. On input letter A, it goes to a dead end. On input letter B, it also goes to a dead end. So it is also the D and D. This is the transaction table. Now we are going to implement this finite automata in Python. For Python, you need to open Colab. Simple write Colab in Google, and it will open this menu. Then simply create a new file like write Colab and enter. Click on this link, Google Colab. Then this menu appear to you. You need to click on new notebook, and I already opened new notebook. You must have a Google Gmail account. You need to log in into this Gmail account. First you need to run this code like pip install automata lib. It will install the automata library for you, and then we are going to create deterministic finite automata machine of all words starting with A over an alphabet A comma B. For that we have automata. We have automata. Automata is actually the automata library. In finite automata, DFA, deterministic finite automata, import DFA. DFA is actually that class which implement the deterministic finite automata. Now DFA is equal to deterministic finite automata, and then deterministic finite automata. And so the first we need to mention states of your finite automata. So these are the states of your finite automata. We have Q0, Q1, Q2 and dead end. These are the states of my finite automata. Q0 is the initial state, comma Q1 comma Q2 on comma dead end. These are the state. Now input symbol, input symbols is equal to A. Input symbols are A and B are the input symbols. Now transactions is equal to, we need to mention all the all the states Q0 colon enter, then Q1 colon, then Q2 colon, then dead end, dead state. Now the transaction of Q0, the transaction of Q0, we have created a state table Q0 transaction. From Q0 in input letter A, it goes to Q1. So on input letter A, it goes to on input letter A, it goes to Q1, comma. On input letter B, it goes to dead end, comma, state number Q1. On input letter A, it goes to Q2. On input letter B, it also goes to Q2. So on input letter A, it goes to Q2, comma. On input letter B, it goes to Q2, same, comma. Now we move to Q2 state. On input letter A, it goes to Q2. On input letter B, it goes to Q2. So on input letter A, it goes to Q2. Also on input letter B, it goes to Q2, second state, dead end. On input letter, if you are going to see input letter A, it goes to dead end, and input letter B, it goes to dead end. So input letter A, it goes to dead end, comma. Input letter B, it goes to dead end. So this is the end of states, comma. This is the bracket beginning with from here to end with here. Now